Okay, so a big note for problem number 6. Because now we don't know the population standard deviation. So we can't do the same thing that we've been doing. Now we're going to have to use the t-distribution instead. And again, there's a whole bunch of reasoning in the book. I'm just going to walk you through the basic steps. And once again, we are going to use Excel to do most of the down and dirty work for us. So part A was asking us to construct an interval estimate with a 90% level of confidence. So let's make sure we remember where in the problem these numbers come from for us to put into the formula. So that alpha level is our level of uncertainty. So since we were looking for a 95% confidence, that's why we've got a 5% alpha level. Our standard deviation right here will be right there. And our n value, that part of the formula, is a sample of 11 items that were drawn. So that's where I got the numbers that I typed into Excel. So this is what it would look like typing it into Excel to get that confidence interval. So then I need to do what I did last time because I got to get an interval. So I'm taking, a range of values. So I'm taking that 920, that sample mean that I was given, and I'm going to add the confidence interval to it. So I'm going to do 920 plus 16.795. And then I'm going to do 920 and subtract 16.795. And that will give me that interval estimate, which I have right here. So that was the lower end of my interval versus the higher end of my interval. For part B, it's exactly the same steps, except obviously you're going to use a different level of uncertainty, because in the previous example, I'm sorry, it's not the level of uncertainty that's different, because it's still a 5% level of uncertainty, along with the 50 is our standard deviation that we got there, and then 11 once again was our n value. Same thing, so I'm going to put this little formula into Excel. It'll get me this, and then I need to do 920 plus that number and 920 minus that number, which gave me this lower and the upper end of that interval. And then part C, you're still doing exactly the same thing, just with different numbers. So the only thing that's changed in each of these is the standard deviation, and that's what part D is all about. It's asking what happens as the standard deviation gets bigger. Standard deviation, in basic terms, is just telling you how spread out your data are. So in this example, in part A, our standard deviation was 25. Okay, so you notice we go from 903 to 936. Now, to get a standard deviation in part B of a standard deviation of 50, so that means the data are a lot more spread out. And then look, between here and here, your interval also got much wider, which that makes sense because the confidence interval is going to have to get bigger if your data are more spread out. And again, this standard deviation tells you how spread those data pieces are. So, good guess. What happens if your standard deviation gets bigger? You guessed it, the interval is going to get even wider. So in other words, as the standard deviation increases, the confidence intervals get wider.